Hello, everybody. It's 6:15 p.m. Central Time on the 24th of August, 2026. It is Monday here in the USA, and I hope you're doing well. Of course, we're looking at the earthquakes here on screen. We've got a new background and a new display, of course, if you haven't seen that over on my live stream on Twitch or on YouTube. Been live a few times on YouTube, but no notices have been sent out. Long story on that. We're not here to talk about any of that, though. We have some seismic activity we need to be brought up to speed on. And if you're not aware, in the past few days over here in the West Pacific, we've seen a now double activity of sixes plus a new six all the way down at the South Pole. We'll get into that in just a second. Let me get a display capture turned on so that you can see the full screen that I have here, and we'll dive back into the earthquakes, get them open for the past several days. So we're going to go back at least a few days here, probably, let's just say 3 days. There we go. So there's our 6.2 down at the South Pole, and this is really the Scotia Sea. Over to the east, we have our letter X, and you know what? Hold on really quick. Now, this is just for looks, right? The shadowing and all that good stuff. Let's bring the sun angle right back. That's just for the live stream again. Again, we don't have to have all the shadows and everything on for this update. But you should be able to see that, again, down here at the Scotia Sea, that's the 6.2, and then a 4.9 struck at our letter X, which is South Sandwich Islands. And what we need to do is go back through the planet to the other side, what's called the Antipode, and boom, we got a 5.8 and a 6.0 on the coast of Japan. 6.0 struck last night south of Hokkaido. 5.8 right down next to Tokyo, in Tokyo pretty much. And that actually got everyone's attention. That was actually like, it made the news over there. It actually shook things up slightly, in case you're not aware of, over in Japan. Normally, if an earthquake this size strikes, it's not that big of a deal, 5.8, unless it strikes in Tokyo or something. And then we do get it on the news. Now, since then, last night, yesterday, going into this morning, a new 6 has struck back over here at Indonesia, but this is east of where we were previously watching. So earlier, last week, we were watching for our large earthquakes, which both hit over in Indonesia. Now we're moving back over towards this way. And over this way, this gets us into where I've got my warnings and watches going, and that's right here. And sorry for my slang terms here, guys, but we're watching and waiting. So 5.2 to 5.3, 4.6, 4.3, this is the spot where all three triangulate in the middle. That's the spot where I've got the warning going. So it's no chance that the middle point is moving now. And hopefully we stay under what I'm looking for. I'm looking for something in the mid-range 7 level or even bigger to strike. Here, new deep earthquake 4.6 raised high off the planet for easy identification purposes. And this is like 500 kilometers down in the plate or underneath the plate. So when we see deep earthquakes, it's like a pressure gauge sign letting us know that something's coming up from down below. And then when it comes up, we get a shallower, larger earthquake next to where the deep earthquakes are. It doesn't stop there, though. Then it spreads out and away across the whole planet and bounces back and forth between the antipodes and so forth. Over towards Europe we go out of the West Pacific, we go up into Burma, Myanmar right here with a 4.6, then another 4.9, this time right in the spot where I issued the warning for the 6. And if you don't remember, just a few days back, it might not be on the feed here still. Oh, it's still there, sort of. Okay, 5.5, 5.6, 5.4, and a 5.9. So we issued the warning and then a 6 hit, but now the exact location has been struck by a 5, 1 magnitude less. So definitely check China off the list if you're keeping track of areas that we warned. First, the magnitude hit 500 miles off. Now the exact location was hit by 1 magnitude less. As we spread out over towards Europe, we get into the Mideast here at Afghanistan on the plate boundary. At this point, I should probably open the USGS plate boundary map to show new viewers, in case they don't know about these red lines here. These are the plate boundaries that the USGS map shows us. And we come out of the West Pacific, and this is the Indo-Australian plate, India, Australia. The outside edge goes up into China, right to where that earthquake struck just east of the plate boundary, and then 500 miles away over here, we got our other 6. Over to the west, we go up into Afghanistan. Then the plate ends and connects into the Mideast and Europe, Asia. But the red lines guide the seismic wave that I'm talking about here over further. Now, notice, the USGS doesn't have anything reported in Europe at all for the last 2 days or more. Let's go ahead and turn on the EMSC to get that European feed. This might ding a few earthquakes and send off an alarm. Now, don't worry, that alarm going off is just me populating the feed, which then gives us the 6s that hit last night. So just wait for it to sound, and it'll end 6.0. That's what you hear if a large earthquake strikes on the stream live. So populating the European feed has just now brought in all the earthquakes for the week. But we're just going to look at the last 2 days. There we go. And you should be able to see it. We're going around the outside edge of Europe to the north, following our arrows, and even to the coast of France. English Channel has now been hit. Check it off the list if you were keeping track of areas that I had warned. Yes, we had warned the English Channel. And it's not that actually big of a deal. It's just a small earthquake. But when you warn and something hits, definitely need to pay attention. It's only in the 2 range, but we're only talking about 2s and 3s going across Europe right now. 3 up in Poland, 2 over here in France, right at the coast of France in the English Channel. Now, the same sized earthquakes, 2.2, 2.3, going down to the south through Spain, and then right here in Spain, major activity's been going on here. Not many people talking about it. A few other researchers, Stephen Burns being one, again, he's on top of these kind of things. Maybe Silky's been talking about it too. South Spain, the swarm that's going on there, and it was a 5.0 earthquake. Now, let's go back to the USGS and show you what's in South Spain. See here? Here's the red line that I told you about again. Comes out of the West Pacific, goes across the Mideast, up into Italy, where it makes a J shape, and dead ends right up here into North Italy at the South France border. But then the plate boundary carries on with Africa over to the west, and then pretty much the subduction stops right here at Gibraltar. And Gibraltar is pretty much where the earthquake swarm is, just east, over on the east side of Gibraltar. But there's something there over to the east. Let's go show you. We're going to go over to Google Earth. We're going to turn on my place marks. And we'll zoom down in on South Spain. Okay, so earthquakes happening down here, right? And remember, I told you there's something over to the east. The, Calatrava volcanic field confronted. I can't say it properly. But we go up to the northeast, and it's nothing but volcanoes along the interior side, going right down here to the south and terminating right here at this volcanic field. And the distance on that is just a few hundred miles at the most. 140 miles? Certainly close enough. And there's probably more down here that are just not marked. But the one up here, let's just get the information on it. 300 different basaltic pyroclastic cones, Mars, and lava domes cover an area of more than 5,000 square kilometers. So, yeah, I mean, we're talking the whole thing right here. And volcanic provinces have to be paid attention to when you get earthquakes along the plate boundaries next to them, as we would all maybe just assume people would pay attention to that. But the subduction stops there. And then we go out to transform fault and other type fault, and according to their key at least, we got a transform and an other right there. Transform other, transform other, transform other. And then we go out to a divergent fault, which is really just north and south facing. That's the Mid-Atlantic Ridge. Let's go look at the Mid-Atlantic Ridge. So we go out here and look what we have. Same-sized earthquakes. So it's a transfer of energy going out to the dead end, which is the T intersection. Let's go to the USGS map here really quick again one more time. Let's recap, because that's like kind of mind-numbing. So coming out of the West Pacific, we go across Asia, drop off 4s. Then the 4s take a step down to low-end 4s as we go across Europe. Once we go across Europe, we take down 3s, going around the outside edge through Poland, and right up across through France, right up to here, to the coast of the English Channel. And then the same-sized earthquake spread out to the west and go down here. And now we have a bunch of 2s. And then we go out here and we have a bunch of 2s. They're all the same size. Now, last week, it was 4s and 5s that did this. So last week, it was 4s going up across Italy, 4.9 striking the outside edge of Europe over at Romania, 4.4 going out to Norway, and the other direction, it was 4.9 to 5.0 going across Italy, was a mid-range 4.5, and then North Africa, and then Spain. So it's last week, it was 100 times more power. This week, so far, the same spread is happening, but it's less in magnitude. Same for up to the north. Instead of the 4.4, you get a 3.2. It's 3s going across Europe right now instead of 4s. But that's about to take a step up, I think, most likely. Over the next several days, I think we're going to increase in magnitude. I think that's just a given with what's going on around the planet. Let's get back to it. What's going on around the planet? 2 new sets of 6s. And the antipodes. Let's go over the antipodes one more time. Let's go back for the whole week now. 6.0 here at Japan and a 5.8 at Japan. Add them together, 6.058 or 6.1 total energy. Go through the planet. 6.2 on the other side struck first. So first 6.2, then these two. But then we have the 6.0 that struck here at Indonesia, and we go through the planet. And there's our 6.7 on the antipode of it exactly. Now, previously, the antipode was Ecuador to Japan, and Ecuador to Indonesia, or I'm sorry, North-South America to Indonesia. And all of that has panned out. Each one has been hit. It has now been 9 different earthquakes back-to-back going from the original 7 upper 7s that went down to 6s or upper 6s, and then went down to now low-end 6s. But it's 9 different earthquakes. You can go back and watch on my channel over the past 2 weeks, and we've been reporting on each one. The back and forth carries on. And again, Japan's antipode is right here at the Travels Underneath point, the exact antipode for Japan. I'll show that to you here right now. We'll just click on the earthquake in Japan, and then we'll come back and hit, I think I just hit Control A. There we go. And boom, right out there. So is it any shock then we get another antipode set of earthquakes going back and forth? We're looking for Alaska to get hit, 6.5. We're looking for over here, right in the middle of this little hot mess that's forming now in the West Pacific at Papua New Guinea, east of Papua New Guinea at Solomon Islands area right in here. We're looking for a potential 7.0 plus. And the final location we're looking for a very large earthquake is down here, south of New Zealand. And that could also go in the 7 range. Over in Europe, we're looking for a 5 in Italy. And look, the halfway point, what would you say the halfway point is between this 4.9 here and this 4.3 here is if we just do a straight line? It'd be right here, wouldn't it? And if we go up and around the bend of the plate and come back down this way and then go back up this way, what is the halfway point? Same thing. South Italy out here in the Tyrrhenian Sea, the halfway point between the 2 sets of quakes. Now, the triangulated 4-way point between 4 earthquakes here then brings us down here into Central Europe. Now, if we get a weird earthquake in Central Europe, like Germany pops off with a mid-range 4 or something, then you'll know that it's spread out even further. But I'm looking down here for our 5 to hit. Okay. And West Coast United States, let's get into this. So, man, did you catch my update? Did you see what happened? I am actually recording right now, at least I think I am. So I should just show the world again what happened, what I found, tell you the story, and bring you up to speed, because this really is truly phenomenal. We got a 4.1 earthquake, rare, over here in western New Mexico on the edge of the North American craton that goes up this way. The edge is defined by the mountains there, and it goes down, goes up through Texas, and back up the East Coast. That's why the arrows are there. This is the way the flow normally goes. Now, I would need to take you back in time, maybe a couple days. So let's go over to my YouTube channel really quick and go take a quick look at my videos. So here's the videos from the past few days, and we go back to this one right here 3 days ago, and about halfway through the video, I'm looking up earthquakes in the United States. And something happens, I find something that literally has me jumping up from the microphone, running out of the room, kind of screaming, because I'm so tired of finding certain weird sites where we're getting earthquakes at them, and I get in trouble for looking them up. And you go watch the video if you want to go get the whole thing on it, but I'll just quickly tell you, at this location, here in the middle of the New Madrid seismic zone now, is a gaseous diffusion uranium processing facility, and it's a Superfund cleanup site where there's been a big radiological mess at the location. And we got the earthquake next to it, right at the military base that's right next to it. And this is where I jumped up and I was like, oh my God, another military base. And oh my God, radiation. Oh my God, here we go again. I'm going to be on every list in the world. I was just getting off every list, starting to make a life for myself. And then I get shut down. And I did. Like, all my videos got limited down to a few thousand views. My live stream on YouTube got limited to 40 people out of 700,000. Do you guys know this? If you're listening on YouTube, you're going to be mind blown. I went live on YouTube multiple nights in a row, guys. Each live stream got blocked. 40 people out of 700,000. Doesn't matter what time of night it is or day it is. It got blocked because I'm talking about this stuff. That's what's going on. People don't believe that, but I mean, come on. Nuclear Regulatory Commission gets the earthquake next to it. I'm the only one willing to talk about it. Everybody else wonders why I'm getting shut down. I got a feeling it's something to do with what I'm showing. So this was a few days ago. So that was in its own right. I explained very low frequency. Now this gets into the next earthquake, and very low frequency, the amount of power that's going into this location is absolutely insane. So we're talking about humans generating low frequency power in the power line, 60 hertz, for instance, and that's on above the surface of the Earth. Down in the inside the Earth, I think there's another type of very low frequency wave, which actually I think I might even be able to show you right here on screen what I think it is. So right now we're looking at the Magnetosphere monitor that I built and released free to the world. If you guys want a copy of this, well, it's out there somewhere. And this is the use of the ACE and Solar 1 data for the Earth's magnetic field. And then we're also using the Bureau of Meteorology data to give us this outside shell of the magnetopause that touches to the outer lines of the magnetosphere. And the magnetosphere is blinking right now at the Schumann resonance here. We have the Schumann resonance turned on, so it's blinking on the Schumann at 7 times per second. And we can turn that up to 14 times per second to reach level 2 if we wanted to when it's like major. But 7 times per second revolution on the blinking. And then you see the particles here, right? See how they're being sucked in towards Earth? Now, do you see this number up here, the red number? That red number is tied to the BZ, and it's negative. And when it's red, the particles turn green, and they're sucked in towards Earth and put through the magnetic field. Now, when it goes the opposite, let's just get that on screen here. When we go green, when we go positive on the BZ, the particles are bouncing off, not reflected. They turn red. Now, there's an area in between both the red and the green that's like a neutral. There's a neutral positive and a neutral negative. And we'll get that on screen to show you. Green goes through. There's a neutral positive, or there's a neutral negative, and then here is a neutral blue right there. So the neutrals kind of doing the same thing. They're either getting bounced off or sucked in, but a little bit less. Now this matters because charged particles are coming in from the sun. The charged particles are very low frequency in their own right, or actually ultra low ELF, and they're electrical. So electricity we're talking about with the charged particles. When they get absorbed into Earth's inner magnetosphere, I think this is going down to the core of the Earth. I can't prove that yet. But when we see acceptance of charged particles going into the Earth and being taken into our magnetic field, down inside of the core of the Earth then matters. Let's go look inside of the core of the Earth. Now, seizure warning, right? Okay, hold on. There we go. So inside of the center of the Earth, right here, they all come together, all the electromagnetic field lines. But then we back it out one, and you'll see they come out of the Earth and are actually pulsating and bending with this twisting of the outer shell of the magnetosphere. Now, this matters because we get down into the core of the Earth. I know it's all mind-numbing, right? Just simply put, charged particles coming in, scuffing their feet across the carpet of the magnetic field of the Earth, which then builds up a charge. That charge then gets taken in with these electromagnetic field lines down to the core of the Earth. Then, deep down inside of the core of the Earth, we get a vibration. This thing starts to vibrate like the bass speaker of sorts, but instead of sound, it's emitting very low frequency. That sound, that low frequency then comes up and spreads out. When it comes up and spreads out, it drops off those earthquakes all the way around the planet that I've been telling you about. But we get into here, and we get the very low frequency generation that attracts the wave to a spot where there's already radiological material that's heavy in nuclear weight, in atomic weight, and then you have electricity precipitating it at the surface. So that's where we get into that on the very low frequency. Now, the 4.1 earthquake out here in New Mexico. So imagine my shock, because in the video, I'm jumping up and running away, and this is 3 days ago at this point. But then yesterday, my viewers started contacting me about the rare earthquake in New Mexico. So let's go put the coordinates in and show you what's there. All the way over to New Mexico we go. And right along here, look at what we have. Wow, your eyes would be drawn to this, wouldn't they? An old ancient volcanic field, Cerro Redondo Volcanic Butte, Cerro Horita. And, I mean, look at it, guys. It doesn't even look like a volcano. It's the ancient remnant of a maar, which is like a certain type of volcano. There's some more pronounced ones that are here if you guys want to see these. Again, it's like an ancient volcanic field. So at first, my eye was drawn to this, and I thought, okay, ancient volcanic field. That's got to be what it is. Let's just look around and make sure there's nothing else weird here going on. Look around, start noticing a few things over to the west right here, and I'm like, what's that? Is that a high school track or something? Looks pretty big for a track. Well, I started to zoom in on the location, and it's not a high school track. And I was like, is that a hill of some kind? Well, to see, we have to actually turn it up at an angle. It looks like a mesa. This thing looks like a mesa. It turns out it's about 100 to 150 feet high, 1 mile long, and a half-mile wide. But what is it? Well, there's no information on the surface at all except for this. When you look at the entrance to the place, it says, Homestake Mining Company Grants ... Grants Reclamation Project, if you click on it more. And now what we're going to do is we're going to jump over, instead of to my YouTube page, we're just going to put this into a search and see what comes up. The Grants Reclamation Project is long-term decommissioning and environmental restoration of the former Homestake uranium mill site. The site, 5.5 miles northeast of Milan and 6.4 miles north of Grants, New Mexico, was operated from 1958 to 1999. 50 years of tailings of radiological material stored at the surface in a giant pile. It's an NRC Superfund cleanup site as well. And the 4.1 earthquake coming in right next to it over here. Let's get our measurement just to see how far it is from the very center of the hill. Now this gets into my video from a couple days ago, 3 days ago. We're 19 miles away, totally close enough. Close enough for what? For an electromagnetic wave in the plate to seek out these spots, as opposed to somewhere else, like a drill point or along the edge of the plate at a volcano directly. But this gets into what I talked about 3 days ago with Lieutenant Colonel Thomas Bearden and what he said about stored radiological material and the earthquakes tied to moving it if you move it at all. So I would propose that a giant pile of uranium that's quote-unquote radioactive, that radioactivity is going to be absorbed in the Earth's magnetic field. And then this gets back to what I just showed you with the real-time magnetosphere monitor. Somewhere on the surface of the Earth, humans come in and introduce more low frequency into a system that's already being pumped with it, and up comes the earthquake to the location where we're doing that. It's 2 NRC sites this week alone, and then we get into what's striking between them. If we go look up all the earthquakes in between here, they're like giant antennas in the ground. Every single location in between these 2 points is a drill point for oil and gas, going down a few thousand feet or more, and at angles. If we're talking about fracking, we can do even horizontal, sideways. But drill points in the ground, acting like strings on a guitar. And this wave is coming across the plate, plucking them along the way as it goes from electromagnetic punch point like that over there at the radiation pile to a drill point like this that's a physical surface perforation. So that is just insane to see. I can't believe it happened again this week. A second radiological site being hit directly next to it with an earthquake. Down to Louisiana, I just showed it to you. Those are drill points over in Louisiana. Up in Oklahoma, I shouldn't need to show those to you up in Oklahoma. 1 million drill points across Oklahoma itself. Same with Texas. Millions of drill points. Every single spot getting hit in Texas is at a drill point. Bar none. And you don't have to take my word for it. You can go pull any Texas earthquake and go put it on Google Earth. I'm randomly clicking on one of them now. What is this? A 2.8. This takes us next to Midland, Texas. You guys know the Bush family was from Midland, Texas with the oil and all that? But let's go put it in and go show you what's there. One should show it. We don't have to show them all. When you see how many there are, you'll get the picture. So right here, zooming in, do you see these? Well, we've got the shadow of a jack of a pump, and Texas is known for its drill points, so it shouldn't be too shocking. But the amount that they've done is actually pretty insane. All of these little white, well, not white, but just carved out areas into the fields, and it just goes on and on. Do you see all these? And on and on and on. Here's a town. And then around town, all the drill points. There's another town. Which one's this? Odessa. And then all around Odessa, all of those little specks on the ground are drill points. And it just goes, I mean, these are whole Texas counties now. I mean, we're talking like, probably a few 100,000 that I just showed you right there alone in drill points. Okay, so that's proof, and then you can go spread out from there. If you want to go do the deep search, if you're a new viewer and you didn't know, Texas and Oklahoma and Louisiana, all drill points. Then we get to the NRC site on the middle of the New Madrid seismic zone. Who would build a gaseous diffusion uranium site in the middle of the New Madrid seismic zone? Isn't that crazy? All right, now let's look even further. Let's go over to the east because we're over in Georgia. We're reaching over to Georgia, southeast Tennessee, and a lone earthquake up here in New Jersey. So I say we go up to New Jersey and go look up the earthquake in Chester, New Jersey. Now, if you're a new viewer, your mind's about to be blown at what I'm about to show you. But I don't want to spoil it for you, so let's go first search this small 1.0 earthquake and tell you a quick story. 2.5 years ago, right before the presidential election, well, maybe about 5 or 6 months, maybe at the most, before the presidential election, Joe Biden is president at that point. And the biggest earthquake on the East Coast of the United States in the past 10 years strikes. It's a 5.0 originally reported. And they downgraded it to a 4.8 if you go look this up. But it struck right in here. And it didn't just struck anywhere right in here. Let me show you where it struck. It struck this field right here. And the only reason I know that it's this field is because of this golf course that's right here called the Trump National Golf Club Bedminster. This is the former DeLorean Company executive, the guy who owned the DeLorean Company. Used to own this estate, and Donald Trump bought it and years ago, and it's the golf club that everybody talks about when they talk about his golf club. And so, here's Donald Trump's golf club. Right behind it, down below it, the biggest earthquake in the past 10 years struck right before the election. Not a word from anybody. I was the only person to cover it to date. Not a mention from any of the weird truther channels, not a mention from the USGS, no one. Just me. And to date, still, no one will admit that the biggest earthquake in the last 10 years for the whole East Coast struck below Trump's golf course before the election. And that's questionable, right? Like, why did everybody ignore it? Even though I made videos telling the world, hundreds of thousands of views on the videos, but still, Nobody, just me, telling everybody about this. After that 4.8 to 5.0 earthquake struck, a line of earthquakes broke out going this way to the northwest, over towards this place called Hell Mountain Preserve. And that's kind of where we trailed off with the earthquakes. But now we're back, and we're just north up here. So I'm wondering what's going on. Now, if I had to guess, just a guess, there's two options on the earthquake, other than it being natural, that there's two options on this. One, they're down there building some kind of base and tunnel digging machine that's going between sensitive areas. Or two, somebody was using very low frequency to look down into the ground below the location to see if they have some kind of underground base or something here. And the way you would do that would be with ground penetrating very low, ultra low frequency. And you would use like a satellite in space that would stretch out a cable of maybe a few hundred miles long that gets supercharged and emits very low frequency. And it goes down in the plate and reflects back off and tells whoever, the Chinese, Russians, or someone else, what's down in the ground in this location. And they could see hundreds, if not thousands of feet down in the ground using that, but it would take something like a space-based antenna to do that. You can't just fly over and do a deep earth-penetrating ground, earth-penetrating scan like that. You need low frequency to do that. And low frequency will induce earthquakes. So we either have a base being built or somebody looking. The odds of it being chance and natural below Trump's golf course are about second to none, man. There's no way you would convince me that that is chance or natural, quote unquote. Especially on the same day that when the earthquakes are striking up here, we tend to see earthquakes strike down next to Joint Base Charleston down in South Carolina. That's what happened in the past. It's not happened today. All right, let's go over on the West Coast. So what's going on the West Coast? Let's turn down our little hexagon size so we can see all the earthquakes. The number of earthquakes on the West Coast has skyrocketed. It has filled up the feed. California, I noticed last night, yesterday afternoon, 2 days ago at the most, Cozo Junction up here. And we're going to click on one of these earthquakes right here in this little cluster. Actually, hold on. Maybe I can turn up the number size. There we go. So this cluster of earthquakes here at Cozo Junction here in eastern California, first it started to pick up in the number of earthquakes. So first it was like 10 or 20 zeros showed up, then ones, then twos, then threes. And when the threes started hitting, everybody started raising their eyebrows, and then the four hit. So something's going on there. You want to see what's at the location? This is where the swarm is at Cozo Junction, far east of LA, over north of the Mojave Desert, north of Ridgecrest. Earthquake swarm is going all the way around this area right here, and you might be able to see a few things that are interesting nearby, like Volcano Peak or Cozo Volcanic Field. We'll start with the Cozo Volcanic Field, which are a bunch of rising obsidian domes, black basalt. Lava is causing that rise over time. Now, next to it, you see all these. This place is also called Little Lake, California, but these little lakes are being used. They're being used to actually put down in the ground. See all the pipelines? The pipelines go out to drill points where they drilled into these volcanoes, literally like on the top of a spatter cone, an ancient spatter cone. They've drilled in and they're injecting water to get steam out. The steam then goes to the turbines and provides electrical power to the area. And of course, they're going to need electrical power out here in the middle of the desert because this is China Lake, where they do all the experimental stuff with the Boeing, Raytheon, and all the companies, plus the U.S. military. They got the rocket gardens right down here where they do all the rocket tests. And yeah, so that's what they need the power there for, most likely. But the volcanoes that are next to it are super impressive looking. So Cozo Field, I just showed you up here with its rising obsidian domes, right? But you can see what happens. Here's one that has not erupted, but right next to it, here's one that has, Volcano Peak. And then you'll see it's happened many times. Ancient buttes covered, younger lava flows down below. Pretty wild, isn't it? So this has happened a lot in the past, and we're on the edge of a volcanic field. But where did it come from? Where did this energy come rolling in from? Well, all we have to do is go back up the coast. We go back up to here. You remember? All the 4 and near 5.0 level activity that struck up here on the north side of California, now we're down south. We're talking about activity down south. And I need to measure and see how far off we are from LA on this. If most people won't care, I know it's just a 4.0 earthquake, but I just want to know for reference purposes how far distance we're talking about from the LA basin. Since this past week we were looking for the activity to come down south, I just want to see how far off I am on date and location. 140 miles. Oh, wait. Yeah, 149 miles down to central LA. 140, all right, so it's within 200 miles for sure, but it's just beyond the warn time, guys. Just beyond the warn time. Again, when we go beyond a time where I issued a warning and then the earthquake hits a few days later, I don't count it as a hit, but I don't keep a list. I don't have some kind of checklist that I'm keeping track on like that. So if it hits within the week afterwards, that's most likely the earthquake we're looking for. Now we've had 2. We had a 4 down here south of Arizona, and now we've had a 4 over here at Cozo Junction. It all comes from the northwest, up here to the Pacific Northwest in particular, and looking up to the northwest out in the Juan de Fuca, you notice there's no significant earthquake activity from all the way up at Alaska, across the Aleutians, back down to the west coast of the U.S. All hush, hush. And I don't like things going hush, hush when the rest of the planet goes into what I would consider to be somewhat of an extreme overdrive on seismic activity. So let's get the smaller earthquakes out of here and just look back at the greater United States, greater whole. Line of earthquakes going down through Texas and up the East Coast. This is one of my biggest discoveries, that there's a flow of seismic energy that goes from region to region over the course of a week, and it's about the same size all the way across. It drops off the same sized earthquakes, equidistantly spaced. Look at Central America, for instance. See the spacing on these? That's no coincidence that they're spaced like that, one overlapping the other perfectly. That's not me doing anything with the hexagons. This is automatically placed by the coordinates from the USGS. They're all the same size. So this helps us to see equidistant spacing on things. And why does it matter if it's equidistantly spaced? We're talking about a very low frequency standing wave going through the plates, being contained inside of these red lines that I've been showing you the whole update from the USGS. These red lines are containing that wave. It's coming up from down below in the core of the Earth, as I showed you here. Now let's animate this up and show you what happens when we're animated. So now you're going to see it's sucking particles in. As it sucks particles in, we'll see it go negative and positive on the BZ and block them off and shoot them in. Do you see that? It's like a fish going through the water, taking a gulp in. This is the most phenomenal simulation now ever, incorporating in the BOM, ACE Solar 1 data, and Schumann. And we get that double toroidal on this that's just phenomenal. Watch this. I can turn up the toroid because there's no sensor for the toroid. We have to bend it. But 30% is way overkill. We could turn it all the way up to 100%, but I keep it down less than 10%, like I would imagine Earth. Our toroidal field is not going to be super extremely strong as it goes out beyond the BOM data here. But in case you wanted to, you could theoretically crank it all the way up to C. And we could also crank it to see solar wind, crank it all the way up to 1,200 kilometers per second. We could turn the toroid strength all the way up. We could also turn the Schumann back on and have it blinking and crank it up all the way beyond what the Schumann could ever do. And there's our end of the world solar storm, right? But we don't need to do any of that. But if you want to simulate those sorts of things, if you have the program, you're welcome to do that. No problem. But the point of telling you about all this is the charged particles that come in, we have ourselves an effect that takes place down inside the core of the Earth. And that then comes up and has an earthquake effect. Wow, look at that. Wow, we've got a yin-yang symmetry going on inside of the magnetosphere right now while it's doing all its twisting. Wow, look at the latticed matrix of that on this double toroidal as it's being generated out from Earth. Again, this is what would happen if the solar wind was 1,200 kilometers per second. If we ever get there, I might just be going down in a bunker or something. I don't think we'll ever be there. And on the toroid strength, if we're at 100%, guys, we're all going to be sticking to the ground or something, or flying off, one or the other. But that, to me, there we go. That's better. So when we're looking at it and we get a good view on it like this lets you know if you see charged particles being pulled in towards the Earth and it's gulping in those charged particles, well, you can certainly expect that there's going to be an increase down with all that energy has to go somewhere. It doesn't just magically disappear. It gets taken down in the core of the Earth. And then the core of the Earth vibrates, as you can see here literally on the screen, vibrating down inside of the core of the Earth. We then get deep earthquakes that come up. So I think this is the force that's causing the deep earthquakes. And it's the force that comes up and spreads out through the red lines. And then that force then drops off equidistantly spaced earthquakes, all the same size, across vast distances in a short period of time. We go in with a 4.9, we come out with a 4.9, for instance. Well, 6.2 resonating back and forth through that core to a 6.2. Well, a 6 and a 5.8. 6.058. You just rounded up 6.1. 6.1 on one side, 6.2 on the other. It's a wave bouncing back and forth. But the wave size is literally the size of the interior of the planet, a huge ELF or greater, even longer wave than ELF. But certainly that length. But now that you get to see this real time, this visually demonstrates something that is so hard to explain to people, right? Imagine trying to explain to people verbally about charged particles coming into the Earth's magnetic field, getting sucked in, taken in, and then reflected back off in some cases, and that's why we don't have huge earthquakes every day. And it's all based upon the incoming charge from the sun. By the way, we can get any view on this, and yeah, that's cool. The head-on view is kind of cool. Looks like a comet coming at us. You can see it taking deep breaths of the solar charged particles. Okay, all right. Well, enough on that. Now, before we end this little update, this is just an update. I'm going to tell you guys, if you want to know where to watch, I've got the updates out over on YouTube with the forecasts included. So what we're watching for California, what we're watching for down in the West Pacific, what we're watching for over in Italy, what we're watching for around the world. Those are all in my videos. We're not going to do another forecast now. This is just your update on what's going on currently. So we're currently at 4s. Just so everybody knows, I think we're going the next step up. We're looking for a new 6 to come in here in the Northwest. And then I'll have to do a new update. We're also looking for a 6.5 in Alaska. We're looking for something like a 7 right here in between these 3 earthquakes. And we're looking for something like a 7 all the way down here south of New Zealand. We're looking for a 5 in Italy. And that's just the tip of the iceberg on the forecast. But those are the big ones I can think of off the top of my head. Oh, 4 is going to, a new near 5 is due in Oklahoma. That's another one. And up to the northeast, I don't know if anybody's even going to care, but we're looking for a 4 in southeast Canada. Like a 4 to 4 point. It could even go up to a 5. That would be actually probably make the news. So they'll probably keep it under that, right? Like if a 5 hits, they'll report it in as a 4. Just to keep it out of the news kind of thing. They totally do that in case you didn't know. But then again, average Joes, they get kind of alarmed by earthquakes when they should just be aware and prepared. It's kind of like, do we all freak out on the weather? When there's going to be severe weather, do we all just go nuts? I don't know. Maybe you guys do. But don't be scared. Be prepared. So in the weather, you would watch the storms coming your way, right? You would probably watch the nightly weather, look at a favorite channel, or maybe just go check the radar even and go look, see what's coming your way. Well, in this regard, you can do this with earthquakes. You can look where the current earthquakes are. You can look where the arrows point, where we expect it to go from those areas, and watch for it to spread, just like a storm. So just like meteorologists would put arrows on a map to tell you which way to watch for the storms to blow, This is which way the earthquakes are guided, because there's this wave that I'm telling you about that's down in the plate that no scientist knows about yet, except for me and my viewers and a few others maybe. Sooner or later, they'll have to admit that it exists and go study it. But right now, it's just me out here showing everybody the obvious signs of it. The way we're going to prove it is to install small VLF antennas about 4 feet to 5 feet wide down in the ground and listen with spectros for a radio wave electric signal to come in. And then that'll prove it. But anyway. So let's save this as a video. Let's put this out over on YouTube when we're done here live on Twitch. And if you are watching on YouTube, you are watching a live recording of me live on Twitch. And I tried going live on YouTube. They limited me to 40 people out of 700,000. All the notices were blocked. I went and complained, and people belittled me on my own pages on YouTube for complaining. They said, stop whining. Now, I think that might be the people doing it to me. Maybe they're Google, YouTube themselves. But anyway, I got told off by a lot of my viewers also for using and making the programs that are free. I don't know, a few thousand different comments were left, not just ones you can ignore. It was enough overwhelming hate about using AI to build the free programs, guys. Now, I know, guys, I know where you stand. I know where a lot of people stand on AI in general. Okay, you've been heard a lot of bad publicity about it and so forth. But the perfect use for AI is going to be to use it to generate scientific tools using data that's been out there for years and to package it in a way that looks good. I don't have hundreds of thousands of dollars and millions of dollars and years of time to make free programs for everyone. So I'm sorry if you're bummed out that I used AI to do it, but to criticize me and so forth was a little bit odd. It was enough that I have to say something now. So the programs are out there, but I took them down off my website. You have to ask me for permission to get them. For the meantime, I've got it here on my end, and if you want to see it, I'll bring it to you. So here's the Magnetosphere program one more time, showing us the charged particles coming at Earth. Very cool program. If you got your hands on it while I released it for free, you're lucky. And the solar program. Let's show you what's going on the sun. So a new coronal hole has formed, as well as a bunch of M-class flare activity coming in here on the sun. This is just, a phenomenal view of the sun here on the program. In case you guys don't know, we also released this for free as well for people to use if you want to get down on the solar. And we got a new coronal hole that is formed here, which I can show you, I think, on the continuum will show it probably the best. Watch for it to form right here. These black dots here on the right. Now, there's already huge sunspots but it just popped up out of nowhere today. Right there. And now we're going to turn something on so we can get our information. We've got the active place marks that are on, and this is active region. They'll give us that from, but we don't need all that information unless you really, really want it. Okay, yeah, right, I'm geeking out. Super geeking, but that's the way it goes. We geek out on the solar information. Backside of the sun, we've got the stereo with the bent image, and of course, we've got the LASCO C2 and C3 running, showing us the outer connections of the sun that sends charged particles towards us. So when you see this thing get super grainy and a whole bunch of charged particles are sent out towards Earth, that then is where we're going in with this. And then what is Earth doing? Is it accepting or is it denying the charged particles? And if it accepts, we then look for an increase in deep earthquake activity and larger earthquake activity. And if it denies the charged particles, well, we get a little break, don't we? All right, it all ties together now. Now I can show it to you visually on a screen. It really makes a big difference, doesn't it? Peace out, guys. Oh, one other thing. If you like my content, you're welcome to support my channel by becoming a member. You're also welcome to support my channel by super chats and any other method that's available there on YouTube. Or if you're over on Twitch, you guys already support me 100%. We don't really need to go too much further on Twitch. But on YouTube, still trying to reach my audience. If you want to support it, please subscribe, like, and all the stuff that you do for all your other favorite YouTubers. I would appreciate it if you did it for me. Peace out, guys. Much love.